Good evening, everyone. This is January 2015, Unit 5 of IAL Chemistry. In this session, I'll discuss MCQs related to this paper. The first question, manganese form a complex with carbon monoxide. Carbon monoxide is a neutral ligand with a formula of Mn2CO10. Oxidation number, because overall compound is neutral, so this is a neutral ligand, so Mn should also be 0. No charge on this. Why no charge? Because overall compound is a neutral compound. If this is a neutral ligand and overall compound is no charge, so manganese also should have 0 oxidation number. Question 2, the reduction of nitrate 5-ion by aluminum in alkaline conditions may be represented by the equation. So for a nitrate ion, it just changes into NH3. Oxidation number, each oxygen is -1, so 3 oxygen will be -6, so nitrogen will be +5. And here in ammonia, because nitrogen is more electronegative, each hydrogen is +1, so 3 hydrogen +3, so nitrogen should be -3. So here +5 changes into +3. So how the +5 changes into +3? So it should gain 8 electrons. And for aluminium, what happened? It changed into AlOH4, and the whole is having a -1 charge. So aluminium is 0, each hydroxide -1, 4, -4. So aluminium should be +3. So 0 changes to +3. If 0 changes to +3, it means it is by loss of 3 electron. But when we write a combined equation, the number of electron lost by one should be equal to the number of electron gained by the other. So the first equation we should multiply by 3. So when we multiply by 3, this will be 3NO3, 8 multiplied by 3, 24, and this will be 3. And the second equation will should multiply by 8. So this will be 8, 8, and 24 electrons. So with NO3, the number X should be 3, and with aluminium, the number should be 8. So X is 3 and Y is 8. That's why D is the right answer. Which of the following is a correct standard hydrogen electrode? The temperature is not 273, it's 298 Kelvin. Sulfuric acid is not used, hydrochloric acid is used. Metal electrode is not copper. We use hydrogen at a pressure of 1 atm. The standard electrode potential of two electrode systems are given. Calculate the electrode potential of a cell. So how we can work out the electrode potential of a cell? The electrode potential of a cell is reduction minus oxidation. And how we identify which one reduction happened? The one which is having a higher electrode potential. So minus 0.4 is higher than minus 0.7. So this one reduction will happen, and another one oxidation. So electrode potential of a cell, reduction, so minus 0.4 minus, and oxidation is minus 0.74. So when we solve, it will come out as 0.34 volts. So B will be the right answer. We don't bother about how many, because that's a standard one, so we are finding for 1 mole. Electrode potential of a cell is positive, but there is no reaction. Like electrode potential of a reaction is positive but no reaction. So it is thermodynamically feasible, but the reaction mixture is kinetically stable. That's why A is a right answer. Because reaction is thermodynamically feasible, it can form a product as the electrode potential is positive, but it is not able to form a product. Why? Because maybe the activation energy is higher, or the reaction mixture or reactants are kinetically stable. Electronic configuration for iron 2. Iron is 56. Iron is 56 and 26. So we have 26 electrons. So when we have 26 electron, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. But this is in terms of energy, but in terms of order, it will be 1s, then 2s, then 2p, then 3s, then 3p, then 3d will have 6 electrons, and then 4s. So when the electrons are removed, electrons are always removed from the last shell. So 4s is having 2 electrons, so iron plus 2 means it lose. So the D will have 6 electrons, singly first occupy, and then there's a pair. So it matches with D. Transition metal compound often have catalytical property. The best explanation, because they can easily oxidize and reduce. And why they can easily oxidize or reduce? Because they have a very small difference in amount of energy required to change the oxidation states. That's why C is the right answer. There are what are the shapes of dichlorocuprate? So two ligands are attached, it will be linear, and chromium 4 are attached, so it will be tetrahedral. For platinum, if 4 are there, it will be square planar, other it will be tetrahedral. So B is the right answer. When a dilute aqueous ammonia is added to an aqueous solution of metal ion, green precipitate, so green precipitate, it can be chromium or iron, and which dissolve in excess of ammonia. So to form a green solution, so this confirms that there is a chromium ion. Iron 2 is dirty green, but it is insoluble in excess of ammonia. Iron 2 ion forms a complex with monodentate ethanoate ion and bidentate ethane dioate ion. The complex with ethane diode is more stable. What is the reason? Because when ethane diode is attached with the metal ion, form a dative bond, so it will displace more ligands from the structure. So the number of the particle in a product increase, or the entropy will also increase. So formation of ethane diode complex produce more particles in the solution. As more particles, entropy increase, so reaction will be thermodynamically feasible. The diagram below summarizes a sequence of reaction involving chromium compound. So when we add a zinc plus sulfuric acid to chromium. So zinc will be oxidized and chromium will be reduced. So this will turn into chromium 2. When we filter and allow to stand, so it will be oxidized by air, turn into chromium 3. Then we add an oxidizing agent, so it will form chromate ion, and then it will form dichromate ion. But here both cases, both substances, oxidation number of chromium is +6. So how many different oxidation states are involved? Chromium +3 is there, that's common. A +2 is there, and +6. So there are 3 oxidation states involved for chromium. All the bond angle in benzene molecule are 120. Which of the following provide the best evidence? So why using an X-ray diffraction we can work out the bond angle as well as the bond length. Valence shell electron pair repulsion theory, using a bond pair and lone pair we can predict the geometry, but it does not follow because the delocalized electron. X-ray diffraction, yes. High resolution NMR is used to identify the number of hydrogen, and infrared spectroscopy is used to find type of the bond, not the bond angle. benzene burned with a very smoky flame, the evidence for the extent to which a benzene molecule is. So this shows that it is unsaturated, because unsaturated required greater amount of oxygen to burn completely. So if it burned with a smoky flame, it means that it is not burned completely, or it is an unsaturated compound. When a bromine water is added to benzene, there is no reaction. However, bromine is added to aqueous solution of phenol, white PPT, antiseptic smell. Basically what happened, phenol, the OH group, the benzene ring in phenol is activated. And how it is activated? Because there is a lone pair on oxygen. So, and this repel the pi electron system, so electrophile can easily attack on this. That's why it activates the benzene ring. So B is the right answer. The repeat unit of a polymer is shown below. What is the structure of the monomer? So to identify the structure of the monomer, we will simply hide the ends and make a double bond between the carbon atoms. So it matches with C. C is there, and then so it matches with option A. Question 16. An organic compound reacts with dilute sulfuric acid to form a colorless solution. So it should be an acid-base reaction, and a white solid on evaporation, so it form a salt, and it will also give a pale yellow precipitate in triiodomethane reaction. So it means next to methyl group, next to carbonyl group, there is a methyl group. So this is a carbonyl group, methyl group is there, and NH2 is there, so A will react. Because this is a test to show the presence of methyl group next to carbonyl, and this one is a test shows as acid-base reaction occur and it form a salt. So A is the right answer. In question 17, an organic compound produce steamy fumes with PCl5, so it means there it can be alcohol, it can be carboxylic, because both gives steamy fumes. But does not react with 2,4-dinitrophenyl hydrogen, so it is not an aldehyde or a ketone. So a compound can be carboxylic acid or alcohol, but it is not an aldehyde. So this is carboxylic acid, but this is also ketone. This one is C double bonded with O, so it is ester, and OH is there, so this will be right. Here again you can see aldehyde, so this will not be correct. So B is the right answer. In a mass spectrum of organic compound, the molecular ion occur at a molecular ion peak occur at mass to charge 86. So which of the following could be empirical formula? We know molecular formula is equals to empirical formula times n, and n is molecular mass divided by empirical mass. Molecular mass is 86, so empirical mass should be a number which can easily divide, like 86 should be divisible by that number, so that we have as a whole number. So when we check for first option, carbon is, so 6 multiplied by 12 plus hydrogen 14, so that is 86. But the empirical formula is the simplest ratio. 6 and 14 can further be simplified, so it means it cannot be A. Then we check the other one, 12 multiplied by 5, that's 60, plus 10 hydrogen makes 70, plus 14, so it is 84. So but 86 will not be divided by 84 completely, so it cannot be B as well. Then C5, so this will be 60 plus 12, 72, 72 plus 16, that will make 88. So this will be higher. If we divide, it will not get the whole number, it will be less than 1. So this cannot be an answer. When we check, so 60 plus 7 plus 19, that will make 86. So this is also making 86 and it is in a simplest ratio. That's why D is a right answer. Question 19, we have propane 1 all. So it will give 4 peaks. If this is A, B, C and D. So for A, the neighbor 3, so it will, the splitting pattern, it will be neighbor 2 hydrogen, so it will be 3. For B, neighbor 3 plus 2, 5, so it will be 6. For C, the neighbor, this is there, this OH will not couple, so 2, so it will be 3. And this is alone, so it will be, next is 0, so it will be 1. So 3, 6, 3, 1, that's why C is the right answer for question 19. Last question, which of the following technique would be least effective as a control measure to reduce the risk when heating a flammable liquid? So when we are heating a flammable liquid, the use of electrical heater will be effective. Using a fume cupboard is used to remove the toxic vapors, gases, but it does not make it like reduce the risk of heating a flammable liquid. Small quantity of a liquid is used. So yeah, that will reduce the risk, that's true. And reflux condenser is there, that's also will not allow the vapors to escape. But in a fume cupboard, when we allow the vapor to escape, that will be least effective to measure the reduced risk when heating a flammable liquid, because fume cupboards are used when poisonous or toxic vapors or gases are given off during a chemical reaction. So this was January 2015, Unit 5 of IAL Chemistry.